Good afternoon, all. Okay, from last session, we are discussing, or we have discussed the testing methods used for the plastic material, and that we have completed tensile testing, flexural testing, and tensile impact energy testing for plastic materials. Now, in the previous session, some I have completed this, but I have collected some information, more information related to the tensile impact energy testing and which standards you have to follow according to the ASTM's standards, that is American Society for Testing and Materials. I have collected that along with the test procedure and specimen size, which specimen size you have to use, which equipment is used for determining the tensile impact energy. Okay, that this information I have collected with the schematic arrangement for a tensile impact tester. This is also known as tensile impact tester or pendulum impact tester. Okay, this is the schematic arrangement, very much similar. This is the digital tensile impact tester. Okay, digital value will be here. Whichever impact will get created after that, you will get the digital value here. Okay, and I will repeat this part. This Okay, I will repeat some part from impact testing, some part from tensile impact testing, and after that, I will move towards the applications of the plastics. Okay, in that some special purpose plastics are there. I have added that at this part only. First three will be special purpose plastics, and after that we will see some applications of the plastic material. Means I will tell you the name of the plastic material and their respective applications. Okay, I have highlighted here the name of particular plastic and its particular components manufactured with the help of that plastic material. And after completing these applications, we will discuss some MCQ questions. I will discuss some MCQ questions from our MCQ booklet only. Okay, so these parts I am going to means discuss in this session. So I will start with the um, okay, impact testing. Okay, in the previous session, I have not mentioned the specimen size used for this impact testing, conducting the impact testing of the plastic material. Okay, now here the specimen size. This is the schematic arrangement for conducting the impact testing. Already we have discussed this. Means I will repeat it in short. This will be the your support, and this will be the anvil. And on this anvil only, you are going to place this specimen, and you have to prepare this specimen, and you have to place it here on this anvil. And after the this one pendulum or hammer will be there. This is the starting position, and this is the swing position or end position of that pendulum, and this is the pointer, and there is one scale. With the help of this pointer you will get the reading with the help of, and that reading you can count it on the scale only. Now on here, you have to take care that don't get confused in between the two impact tests. Okay, Charpy impact test is there, and IZOD impact test is also there. But for the plastic materials, generally, almost for all plastic materials, we are going for the IZOD impact test. Okay, IZOD impact test is used for the plastic materials, and for conducting that IZOD impact test, the standard specimen is prepared with this mentioned dimensions according to the ASTM standards, and these ASTM standards will be like this: ASTM D256. Okay, ASTM D256. According to these standards, you have to do the test specimen preparation, and you have to follow the particular test procedure. Okay, so standard dimensions will be like this: 640 by 12.7 by 3.2 millimeter. Okay, then the most common specimen thickness. Okay, this 3.2 is nothing but the specimen's thickness. This is the commonly used, and sometimes you can go for 6.4 millimeter also. Okay, and why we are using this higher or a larger thickness? Because sometimes with the minimum thickness, that component may get subjected to the it may get bent. Okay, it may get bend. To avoid that, we are going for, sometimes you have to go for the larger thickness also. Then here the depth of the notch they have mentioned here. You have, whichever specimen is prepared, one notch will be there, and that notch will be of 10.2 millimeter. Okay, you have to prepare a notch, and where to prepare the notch? Okay, here. Here I have collected some comparison points between the impact testing which we are using for the plastic materials. Okay, that is nothing but the ISOD impact test. V notch you have to prepare. V notch you have to prepare. Then another things you have to consider the position of the specimen. The position will be vertically. You have to place the that specimen in that anvil, and the notch should be facing towards the pendulum only. Okay, means whichever notch here. This is your anvil. You have to place the specimen vertically, and whichever notch you have created, it should face the hammer. Okay, face of that notch should be towards this direction, means towards the hammer. And these are the dimensions, specimen dimensions here. You have to refer it for this plastic material only. Okay, 64 length, then width, and this is the thickness. 3.2 will be thickness, 12.7 will be the width, and 64 will be the length. Okay, and this standard used is ASTM D256. This is the impact testing. Okay, impact testing used for the plastic material. Whichever resistance here we are indirect, means we are directly measuring here whichever resistance is provided by that plastic material to the sudden impact, that we are going to take, or we are going to measure in this case. This is the impact testing. Now after this impact testing, the next is the tensile impact energy testing of the plastic component. Okay, please, you can write down the name. Please write down the name for each. We have to collect one, make one table on a, consisting of two columns. On the left side, write the name of the test conducted, and on the right side, you have to mention the whichever, you can say that the uh, standards, ASTM standards used. Okay, from first test, I will repeat it again. Okay, these standards are very important. Okay, for the tensile testing of thick components, ASTM D638, and tensile testing of thin components, ASTM D882. Then for flexural test, ASTM D790. And then for impact testing, ASTM D256. And on the tensile impact energy testing, ASTM D1822. Okay. Now here, we are also following the ASTM D256 standards. Okay, in this tensile impact energy testing. When we are going to follow this, whenever we are having very thin component is there, very thin component, at that time only we are going for the changing the standards, and we are using the standards of ASTM D256. Otherwise, we are using ASTM D1822 only. Okay. Now here I will repeat, some part may get repeated. Okay, this is the tensile impact energy testing of the plastic material. Now why we are conducting this test, or how we are conducting this test? Now this test, we are going, in this test we are going to measure the amount of force needed to break a specimen under the high speed tensile load introduced through a swinging pendulum. Okay, in this also, here this will be the support, and this will be your anvil. Okay, this is the anvil for a tensile impact tester. Okay, this is the tensile impact tester, and here we are going to calculate or determine the tensile impact energy, and this will be the base or support, you can say that. And here is the anvil, and here we are going to fix the specimen. Okay, now specimen will be horizontally placed. It will be horizontally placed. It will be like this, in this direction. From here to here. One end will be fixed in this anvil with the help of this anvil, and another end will be free. Means it will be in such a way that it will form a cantilever beam. Okay, in case of impact testing, the specimen is placed vertically. Okay, in this direction, placed like this vertically. But in case of the tensile impact energy testing, it will be placed horizontally like this. In the horizontal direction, one end will be fixed and other end it will be free. And on that free end only, this pendulum will strike, or it will create its impact on that free end only. Okay, now we will move towards the test procedure. Initially, we will measure the dimensions. Here they have mentioned that the thickness and width of the test specimen is recorded. Means just you have to prepare the specimen as per the standards. Whichever standards you are following here, in that standards only the standard specimens dimensions will be mentioned. As per this standard ASTM D1822, you have to prepare that specimen. Then specimen is then clamped to the crosshead. Crosshead is nothing but anvil. Okay, there you have to fix that specimen, and then pendulum is released and allowed to strike to break the specimen, and the tensile impact energy is recorded. Okay, so this will be the test procedure. What you have to write in the test procedure: initially, first step will be test specimen preparation. Then after specimen preparation, you have to fix that specimen here, and you should fix that in such a way it should form a cantilever beam. You have to place it horizontally. In case of tensile impact energy testing, it should be placed horizontally, forming a cantilever beam. One side end will be fixed and one end will be free, and on that free end, this pendulum will strike. Okay, it will strike on that free end, and due to this strike impact, and as it is a cantilever beam, some tension is also created along the length, and that component is breaked, and you have to collect the readings, the value which is which you are getting at the end. It will be termed as tensile impact energy. Okay, in the next point, they have mentioned the whichever dimensions, standard dimensions you are using here. All these specimen sizes you will find in the that ASTM D1822. These standards. Why we are following certain standards? In that standards only they will mention the specimen preparation, dimensions of that specimen, the test procedure, and how to collect the readings. All that will be mentioned in that standards only. Okay. Now in this case, you can prepare the specimen in two ways. You can prepare one long specimen, and you can also prepare a short specimen. Okay, it will be denoted by L, and the short specimen will be denoted by S. Whenever you are preparing the long specimen, then here the gauge length is 9.53 millimeter. Okay, gauge length is 9.53, and in the S type specimen, that is the short specimen, means they have not exactly mentioned the gauge length. Okay, they have not provided the exact value of the gauge length. According to, depending on that material, you have to prepare it accordingly. Okay, and the next is the data which we have to collect, that is the tensile impact energy is recorded, and whichever equipment you are using here, that is termed as pendulum impact tester. Okay, pendulum impact tester or tensile impact tester. So in this way, and we are going to conduct that tensile impact energy testing. So in this way we have completed this part. Already I have completed it, but I have collected some more information related to the specimen preparation, and some schematic arrangements or testers used. This is the digital tester. Now we will move towards the next part, applications of the plastics. Okay. I'll take a pause here, 1 minute's pause. You can write these applications according to the material. I have collected the applications almost 17 18 plastic materials I have listed here. Okay, and their specific applications I have highlighted. Okay, almost 18 plastic materials I have collected here. This is combination of thermosetting as well as thermoplastic. Sorry for disturbance. Wait for 1 minute. Please note down the name of the plastic material and its related components, or you can say that the components manufactured from that particular plastic material. Okay, here I have collected thermoplastics as well as thermosetting materials. Okay, I will finish the applications. Some 17, 18 plastic materials I have highlighted here, and after completing the applications, we will move towards some MCQ questions also. Okay, and after completing the MCQ question, this first chapter will be finished here only. Okay, so I will start here. The first material, melamine formaldehyde. Okay, this melamine formaldehyde, it is denoted or it is indicated by symbol MF. Melamine, M stands for melamine, F stands for formaldehyde. This is melamine formaldehyde, and this is used for manufacturing of the it is used for manufacturing of the moldings of ceramic cups, then plates, ceramic cups, ceramic plates, or ceramic bowls, and a decorative top surface layer. Okay, so one decorative layer is there on the paper laminations. One decorative layer is there. That layer is manufactured with the help of this melamine formaldehyde only. Okay, I will repeat it again. It is used for manufacturing of molding of ceramic cups, ceramic plates, ceramic bowls, then decorative top surface layers of the paper laminates. Okay, this is the first plastic material and its applications. And next plastic material is phenol formaldehyde or phenolic resin. Okay, phenol formaldehyde or phenolic resin. It is denoted by letter PF, that is phenol formaldehyde, or phenolic resins or phenolics. They are denoted by letter or symbol PH. Okay, capital PH. Now, these phenol formaldehydes or phenolic resins, what is their? They are having certain applications, or they are used in the insulating materials. Suppose you are using some electrical equipments, in that it is used as a insulating material, or it is used as a used in the thermal insulating foams. And why it is used there? Because it is having a very high heat resistance and fire resistance capacity. It is having a certain property, that is, it is having very high heat resistance capacity and high fire resistance capacity or ability. That's why it is used in the manufacturing of the insulating parts, which we are using in the electrical fixtures or some thermal insulating foams or paper laminated products. Okay, to protect that component from the fire and heat, we are using this phenol formaldehyde or phenolic resin material. And so this is the phenol formaldehyde. It's some properties. and due to that properties only they are having some important applications. And after this, the next is polyepoxides. Polyepoxides, and these polyepoxides, these are used, or they will act as a adhesive. Okay, to it will used as a adhesive material. Adhesive means it will help to join the two different materials. Okay, and it is very helpful to make the different composite materials. Okay, as you have studied in the concept of the composite materials, you have to use, or you are going to make new composite materials with the help of different compositions. Okay, you may use metal and plastic, or you may use another kind of the different combinations you are going to use here. And to join that different metals to the fibers, or different metals to the plastics, okay, to join that, you needed one adhesive, and generally we are going to use this polyepoxides because they are having the excellent adhesive properties. Easily they will join the different materials. That's why we are using these polyepoxides as adhesives in the different composite materials. Okay? And we will move towards the next slide. And the next is the polysters. Okay, polysters. These are denoted by letter PE, capital P and small s. Polysters. Okay, don't get confused between the symbols of polyethylene. Polyethylene is also denoted by P, but just P will be there, and in polysters, P's. Okay, P's. It will be like this. Small s will be there. These polysters, already I think you have aware about these polysters. These polysters are generally used in the manufacturing of the fibers or fabrics. You can say that the fabrics which we are using in the clothing. In the clothing fabrics, this polyester is used. Then while using our computers or laptops, we are suppose sometimes you are attaching the mouse to that laptop also. Whichever mouse is there, for keeping that mouse, one mouse pad is there, that mouse pad is made from this polysters only. Mouse pad, okay. Then clothing fibers, then many home material, furnishing materials like bed sheets, some curtains are there, blankets, and pillowcases. All these are manufactured with the help of the polysters only. Okay, these polysters, it is used in the manufacturing of the clothing fabrics, mouse pads, then many home furnishing materials such as bed sheets, curtains, blankets, pillowcases. For all these polysters are used. Then next is PET, that is polyethylene terephthalate. Okay, PET, polyethylene terephthalate. Okay, this polyethylene terephthalate, it is having excellent properties, like it will act as a barrier. It will act as a barrier material for water and moisture. Okay, it will act as a barrier material for water as well as for moisture. That's why it is used to manufacture the plastic bottles. Then plastic bottles. Now different plastic bottles are manufactured with the help of this PET only. Polyethylene terephthalate. Okay. Why we are using this PET only? Polyethylene terephthalate, because it will act as a excellent barrier material for water and moisture. Okay. These plastic bottles are having wide applications. We are using these plastic bottles for storing the water. Sorry, plastic bottles for storing the water, as well as these plastic bottles we are using to store some soft drinks. Okay, soft drinks, carbonated soft drinks are there. Lots of soft drink bottles are there. Then plastic bottles in which water is stored, that water bottles. All these are manufactured with the polyethylene terephthalate because it will act as a barrier for the moisture also, or it will protect that particular drink or water from the contamination. Okay. Then it is also having the high mechanical strength. That's why it is also whichever tapes are there, whichever tapes are there made from the polymer material, that tapes, measuring tapes that are also made from this polyethylene terephthalate, because it is also having the high mechanical strength, or you can say that high tensile strength. Okay, it is used in the manufacturing of tapes and plastic bottles. And why it is used for that application? For manufacturing plastic bottles, it is having excellent. It will act as a barrier material for moisture, and it is also having the excellent tensile strength. That's why it is used for manufacturing of the tapes also. Then next is the polyethylene. This polyethylene, it will be indicated by letter PE. Now this polyethylene, it will be used in the manufacturing of inexpensive, you can say that the market bags, then some plastic bottles which are, yeah, you can say that which are having very low cost, that will be manufactured with the help of this polyethylene. The bottles, plastic bottles which are having higher cost, that will be manufactured with the help of this PET, that is polyethylene terephthalate. And the low cost plastic bottles, it will can be manufactured with the help of this polyethylene. And some plastic bags can also be manufactured with this polyethylene. Whichever bags which we are using in our day-to-day life while buying, carrying that vegetables, all that bags are made up of this polyethylene. Okay. Next is high density polyethylene. Okay. And then the next is high density polyethylene. Okay. Now this high density polyethylene, this is denoted by HDPE, that is high density polyethylene. Now application of this, we can say that in your agricultural field, I think we have seen that black colored pipes which we are using to water our plants. Okay, black colored, small diameter. It is having very small diameter. Black colored pipes are there. Okay, that black colored pipes, these are manufactured with the help of this HDPE material only, high density polyethylene. Then other applications you can write, is used for manufacturing of shampoo bottles. Whichever shampoos we are using, that shampoos are stored in one bottle, plastic bottle. It is made up of that HDPE. And different kinds of the toys. Then for storing some chemicals, some containers are required. That chemical containers are manufactured with the help of this HDPE material only. Then different pipe systems. These we are largely using in the agricultural field. That pipes will be manufactured with the help of the HDPE only. Okay, wait, I will show that HDPE pipes in this. Okay, I will show that on the screen. Okay, are you able to see this? Uh, these are the HDPE pipes. Okay, is it visible clearly? These are the HDPE pipes which we are using in the what you can say that in the agricultural application for watering our plants or whichever vegetables or farming we are doing, for providing the water to all plants. We are using these kinds of the pipes. These are HDPE pipes. These are HDPE pipes, high density polyethylene pipes. Okay, and then next is PVC pipes. Okay, PVC pipes, I will also show that here only. PVC pipes also. If you see that practically, it will be very easy to understand. PVC pipes, okay, that white colored pipes, okay, that white colored pipes are PVC pipes, okay, and it may be available in the different forms, okay, it may be in the form of cup, what you can say that coupling, it may be in the form of T-shaped pipe or any kind of okay, here you can see here, okay, if possible I will copy this image. It is, okay, so these are you can say that these are the different components manufactured from the PVC material. That is polyvinyl chloride. All these we are using in the plumbing operations. Okay, whichever pipes are there in our home. Okay, to take the wastewater from our home to the drainage line, you can say that these are the PVC pipes. Okay, it may be in the form of a pipe, it may be in the form of a coupling, or this T-shaped joints will be there. All these are manufactured from the PVC. This PVC is nothing but polyvinyl chloride. Okay, drainage pipes you can say that, or water service pipes. Then other important applications of this polyvinyl chloride are window frames are manufactured. Then drainage pipes and water service pipes. Already I have told you this. Then some medical devices, that syringe, nowadays the syringe is used, okay, whenever some extra means you need you are feeling very weak, that glucose bottle uh, is there, and that they are giving it through our you can say that with the help of that syringe, okay, that syringe is made from that PVC material, polyvinyl chloride. Then that blood is stored in the PVC bags only. That blood storage bags are there. Okay, blood storage. Sorry for disturbance. Blood storage bags are there. That blood storage bags are also made from that PVC material, polyvinyl chloride material. And then some cables and wire insulations, then some resilient flooring, roofing membranes. Okay, flooring and roofing membranes. Then automotive, whichever vehicles are there, automobile vehicles are there, four wheelers, their interior parts or whichever seats coverings are there. Okay, sometimes in the footwears also this polyvinyl chloride is used. Okay, then next is PVDC. Okay, polyvinylidene chloride. Okay, this is polyvinyl chloride. Next is polyvinylidene chloride. Polyvinyl chloride is denoted by PVC, and polyvinylidene chloride is denoted by PVDC. And this PVDC has some specific applications used in the manufacturing of the packaging, and that packagings we are used for packaging of the foods, then drugs, whichever tablets that are given to us from the doctors, okay, which we are purchasing from the medical, that tablets are packed whichever packaging material is there for that tablet, that is nothing but our PVDC. Okay, PVDC is polyvinylidene chloride, and it is used for packing the foods, drugs, some cosmetics. So next is polypropylene. Next material is polypropylene, is denoted by letter PP. Then this polypropylene material is used for packaging of the consumer products, and it is also used for manufacturing of some plastic parts. That plastic parts we are using in the automobile industry. Okay, and then it is also useful in the textile industry also. Then next is the polystyrene, that is the PS. This PS material we are using in the food packaging, Then whichever laboratory wares are there, means different instruments or wearables are there made from the plastics, so that we will be able to keep safe from the different chemicals. Ourselves we are protecting from different chemicals in our labs. That different laboratory wares are made from this polystyrene. Then this polystyrene is used to make different kinds of the electronic appliances, then different automobile parts and different toys, whichever toys are there. Small children are playing with that toys. That toy is consisting of abcd. You have to plot that abcd symbols are there, or they have to make some, you can say that they will provide one picture and they will provide you small parts. You have to join that parts. That kind of toys are there. That toys are made from this polystyrene only. Okay. Then gardening pots are there made from the plastic, that are made, that is nothing but the polystyrene. Whichever gardening pots are there in the gardens, some small pots are there in which you are means planting some flowers like that. Okay, that pots are made from the polystyrene only. Then after this, next is the high impact polystyrene. Now this high impact polystyrene, it is having glass like texture. Okay, it is very much similar to the glass. Now it is used in the okay, it is used for storing the or you can say that it will act as a container for the yogurt. Okay, to store that yogurt, one container is required. And then different salad bowls, then refrigerator linings, then medical, in the medical field lots of trays are there. All these are manufactured with the help of this high impact polystyrene. Sorry. Next is ABS. Okay, this is very important material, ABS. And this ABS material you can modify it by adding this one extra ABS, two extra ABS materials are there: polyethylene ABS and polycarbonate ABS. Okay, it is just before understanding these two materials, I will explain this ABS. Okay, long form for this ABS is acrylonitrile butadiene styrene. Okay, I'll repeat it again: acrylonitrile butadiene styrene. And it is used for manufacturing of different electrical components, whichever keyboards, computer keyboard is there, our computer monitor, then printers, then lots of toys are there. Okay, lots of plastic toys are there, that all are manufactured with the help of this ABS. And again, whichever I have told you that toys means children are playing with that toys consisting of different small parts. That toys can also be manufactured with the help of this ABS, acrylonitrile butadiene styrene. Okay, I will repeat it again: whichever computer components or different component parts are there, like keyboards, then monitor, printers, all these are manufactured with the help of this ABS only. Okay, then different pipe fittings, then toys, Lego toys. Okay, these are Lego toys means you can fix it on the board. Okay, can fix the toys on the boards. Then the next is the polyamide. And this polyamide is used in the textile industry, then and the automobile industry, and different kinds of the kitchen utensils, the small equipments which we are using in the kitchen. That utensils are manufactured with the help of this polyamide. Then different kinds of the sportswear, different kinds of the sportswear having high durability and strength. That different kinds of the sportswear, it may be your shoes, or different that tracking sports shoes are there. Then different sports wear may be there, maybe sports wearing jacket having high durability and strength. And then gloves, all these can be manufactured with the help of this polyamides. Then polycarbonates, it is denoted by PC. It is okay, its specific application. Nowadays you can see that whichever uh, specs you are wearing, specs, that specs are having some lenses or eyeglasses are there. It consists of some eyeglasses. that eyeglasses are manufactured with the help of polycarbonate. Okay, it is PC material. Eyeglasses, then different traffic lights, different lenses are there. Uh, then security windows, compact discs, all these are made from the polycarbonate only. Then after this, the next is polyethylene ABS. Okay, this is nothing but combination of ABS and polyethylene, and it is used in the manufacturing of low duty dry bearings. Then polycarbonate ABS, it is combination of ABS, acrylonitrile butadiene, styrene, and polycarbonate. It is termed as polycarbonate ABS, and it is generally it is used. You can say that whichever interior is there in our four wheeler, you can say that in the car, or our different SUVs, whichever interior is there, that interior is made from this polycarbonate ABS. Then whichever smartphones we are using nowadays, light-weighted smartphones, it's that mobile phone body is manufactured with the help of this polycarbonate ABS. Then we are using laptop. That laptop case is manufactured with the help of this polycarbonate ABS. Then already I have repeated this in the ABS, that is keyboards, monitors, and then here automotive IP retainers, then wheel covers are there, then tractor hoods. This tractor hood is nothing but the uh, you can see that the top surface. I will show that in the picture. Tractor hood may be easily understood for you after seeing the picture. Okay, it will provide the some safety for driver from the sunlight also. Tractor hood. Okay, okay. This tractor, this top surface, this is the tractor hood. You can say that the top surface. Okay, this is made from polycarbonate ABS. Okay, is made from the polycarbonate ABS. Then next next, and you can say that this is the polyurethanes. This is the last part, or number of polymeric materials are there, plastic materials. But for application purpose, I have collected this 17, 18 only. This is the polyurethanes. It is denoted by PU. Now, this polyurethane, you have understood, means lots of times you may have heard this name, that is PU foam. Whichever mattresses you are using nowadays, mattress, okay, that is nothing but, and in that PU foam is there, PU foam, or you can say that in your whichever sandals you are wearing, maybe you have heard this word PU. Okay, it is made from this PU foam, or PU sole is there. Okay, I think you have heard this word PU foam or PU sole is there. It is nothing but the polyurethane. Okay, so this polyurethane foam is having various applications. Okay, it may be used in the mattresses or some. Okay, here I have highlighted some. It is widely that polyurethane foam is widely used in the flexible foam seating, in rigid foam insulation panels, then microcellular foam seals and gaskets, then durable elastomeric wheels, then tires, then automotive suspension bushings are there. Yeah, different components are there in the electrical field also. And simply that PU foam you will able to see in that mattress. Okay, orthopedic mattresses are there or normal mattresses are there, in that this PU foam is present. Okay, this is nothing but the polyurethane. Okay, in this way, we have completed this application part. Now after these applications, I will move towards some, you can say that, some MCQ questions. Okay, MCQ questions. I think it may be visible. I will zoom it again. Okay, the first question. Okay, I will solve it. The dash dash are the, you can say that, are the filler materials. Out of these four options, which material you are adding to the plastics to improve their mechanical properties? Okay, here they have given you options like fillers, plasticizers, enforcing agents, and none of the above. Okay, which material you are adding to the plastic to raise their mechanical properties? The answer will be reinforcing agents. Okay, and then the polymers are having large chain molecules, and their molecular weight will be in the range of this 104 to 107. This will be the answer. uh, this is not in actually in your syllabus, just I had added this for your information only. And next is, in addition polymerization reaction, polymer is formed in a single stage. In addition polymerization, single stage will be there. Then one more question for improving your information. This is the question. In case of processability testing, this capital MI stands for, okay, capital MI. This is for melt index. Okay. Then now this is in your syllabus. Epoxy resin is an example of. Already we have discussed this. Epoxy resin is an example of, you can say that this is a thermosetting plastic. Okay. Then the polymers can be very, means it will be very resistant, or it will be very opposite, or it may be very similar. Out of this, it is very resistance to the chemicals. Polymer will provide you the resistance, means for different chemicals it will provide resistance. Then randomly I will take this last one. Which of the following is an additive used for saving the price, you can say that, or saving the basic plastic material? Now here we are adding the fillers to save the cost of the plastic material. We are adding the fillers. Okay. And then next is, which adhesive, sorry, which additives you are adding to improve the flow characteristics and decrease the brittleness? They have given the options stabilizers, colorants, or plasticizers. Answer will be plasticizers. We are adding plasticizers to improve the flow characteristics and to decrease their brittleness. Okay, some more. Okay, few I have collected here. Okay, one or two I will read it. Okay, the material which softens on heating, and solidifies or hardens on cooling. Okay, you have to name it. The material, plastic materials which softens on heating and hardens on cooling. These are thermoplasts. Okay, answer will be thermoplasts. Then the last objective MCQ question I will take here. In which polymerization method monomer react by eliminating the small molecules in repetitive manner? Okay, in which polymerization method the small molecules are eliminated? Means small molecules are eliminated means one byproduct like water or some salts are formed. This takes place in condensation polymerization. Okay, this takes place in condensation polymerization. Okay, in this way we have discussed. You can go through this MCQ booklet. Okay, here I have collected some 9 to 10 MCQ questions, and their answers are also provided. You can go through it. Okay, so in this way, in this session, what I will summarize this session now. We are at the end. Those who have joined late, you can put your attendance. After a few minutes, I will stop this session. Okay. Now, what we have learned in this session, we have learned the impact testing, how impact testing is performed on the plastic material using ASTM D256 standards, and how the tensile impact energy testing is performed on the plastic material using ASTM D1822 standard. Then this tensile impact tester, its constructional details and the test procedure. And after that, we have discussed various applications of the plastic materials according to their names like melamine formaldehyde, phenol formaldehyde, polyethylene, polypropylene, and polyethylene terephthalate, HDP, that is high density polyethylenes, PVC, then PVC is nothing but polyvinyl chloride, then ABS, okay, acrylonitrile butadiene styrene, then polyamides, polycarbonates, polyurethanes, okay, different plastic materials along with their applications we have discussed here, and we have taken some MCQ multiple choice questions also. In this way, we have completed this first chapter, Introduction to the Plastics. Okay, in this we have completed the concept of the plastics, then its classification. We have seen the comparison points between thermoplastic and thermosetting materials. Then we have discussed properties of the plastic materials. Then different additives which we are using in the plastic materials to improve their properties, and different testing methods, tensile testing, impact testing, tensile impact energy testing, flexural testing. We have seen that also. And after that, we have discussed the applications. Okay, applications also we have discussed. And one more point I have forgotten, that we have also completed the concept of monomer, polymer, and polymerization along with their types like addition polymerization, condensation polymerization, copolymerization, and coordination polymerization also. Okay, so in this way, we have completed this first chapter. Maybe in the next week, I am going to conduct one MCQ test on this first chapter only. I will share the link, and you have to solve that test within that specified time. Okay, in the next week, I will provide it. Probably on Tuesday or Thursday, I will try to provide it in the next week. MCQ test will be there on this first chapter only. Okay. In this way, we have completed this first chapter, Introduction to the Plastics. In the next, I think on the Monday or Tuesday, uh, we will move towards our second chapter, that is processing of the plastics. Okay, now I will stop today's session here only. If you are having any query, you can put that in the chat box. Or if you are not having any query, I will conclude this session. Thank you for attending this session. You can continue with your remaining sessions. Thank you.